them is my real test. To train them is my cause. Pokemon, gotta catch 'em all. It's you and me.
Greetings, viewers! We are here to discuss on how to solve the 4 conic sections in pre-calculus. But first, what is conic sections? Conic sections is the intersection of a plane and a right circular cone. The 4 basic types of conic sections are parabola, ellipsis, circle, and hyperbola. The first conic section that we will be discussing is circle. Circle is a set of all points in a plane that is equidistant to a specific point called center. The standard equation of a circle is quantity x minus h quantity squared plus quantity y minus k quantity squared equals radius squared, where its center radius form is c quantity h comma k quantity r. Moving on to the general equation of a circle, the general equation of a circle is ax squared plus by squared plus cx minus dy plus e equals 0. Now, let's have an example. For this example, we will be having 4 and 7 as a value of center in h and k and a radius of 6. To solve for the standard equation, we will be substituting the given terms in the standard equation of a circle. Thus, the value will be quantity x minus 4 quantity squared plus quantity y minus 7 quantity squared equals 36 as your standard equation. For the second step, we will be converting the standard equation into the general equation of a circle. We will be expanding the squared binomials. It will be x squared minus 8x plus 16 plus y squared minus 14y plus 49 equals 36. After that, we will be transposing 36 to the left side of the equation, making it x squared minus 8x plus 16 plus y squared minus 14y plus 49 minus 36 equals 0. Lastly, we will be arranging the order of the equation and combine like terms, making it x squared plus y squared minus 8x minus 14y plus 29 equals 0. And it will be your general equation. Let's have another example. For this example or number, we will be having 2 and negative 4 as a value of h and k in our center, and we will be having a radius of 5. So just like what we did before, we will be substituting the given terms. Quantity x minus 2 quantity squared plus quantity of y minus parenthesis negative 4 close parenthesis quantity squared equals 5 squared, having quantity x minus 2 quantity squared plus quantity y plus 4 quantity squared equals 25 as your standard equation. Next step is to expand the 2 square binomials. Thus, x squared minus 4x plus 4 plus y squared plus 8y plus 16 equals 25. Then, we'll be transposing 25 to the left-hand side of the equation, making it x squared minus 4x plus 4 plus y squared plus 8y plus 16 minus 25 equals 0. Last step is to arrange the order of the equation and combine like terms. Thus, x squared plus y squared minus 4x plus 8y minus 5 equals 0 is your general equation. So now that we know how to find the general equation of a circle from the given properties h, k, and r, next is I am going to teach you how to find the center and radius of the circle from the given general equation. Now, let's have an example. X squared plus y squared plus 6x minus 12y minus 4 equals 0. So first, is we have to group them to their corresponding partners and transpose the constant term to the right side. Open parenthesis x squared plus 6x plus blank, close parenthesis, plus open parenthesis y squared minus 12y plus blank, close parenthesis, equals 4. As you can see, I put blanks as I group the variables. So, in order to transform this equation into a standard form, we can now complete the square of the groups by adding perfect square numbers. So, of course, if you add corresponding numbers to the left-hand side of the equation, you should also add them to the right to make the equation balance. And now we have quantity x squared plus 6x plus 9 plus y squared minus 12y plus 36 equals 4 plus 9 plus 36. Then, we add the numbers on the right side of the equation and factor out the groups on the left side and make it two perfect squared binomials. And now, we have open parenthesis x plus 3 close parenthesis squared plus quantity y minus 6 squared equals 49 as your standard equation. Now, given that we found the standard equation, we can now easily identify the properties of a circle: center, h, k, and radius. So for the properties, we have h equals to -3, k is equals to 6, and then we have a radius of 7. So this is how you'll write it. Another example, we have x squared plus y squared plus 2x plus 10y plus 10 equals 0. So just like what we did before, group them into their corresponding partners and transpose the constant term to the right side. It will be quantity x squared plus 2x plus blank plus quantity y squared plus 10y plus blank equals -10. Next is to complete the square of the groups by adding perfect square numbers. Always add them on both sides to make the equation balance. Thus, it will be x squared plus 2x plus 1 plus y squared plus 10y plus 25 equals 10 plus 1 plus 25. Then, we will be adding the numbers on the right side of the equation and factor out the groups on the left side and make it two perfect squared binomials. Now, we will be having quantity x plus 1 squared plus quantity y plus 5 squared and equals to 16 as your standard equation, having the properties of h is equals to -1, k is equals to -5, and a radius of 4. And this is how you will write it.
The next lesson is solving parabola equations and its properties. But first, what is parabola? Parabola is a set of all points in a plane which is equidistant to a specific point called focus and a specific line called directrix. Properties and equations in parabola varies in horizontal and vertical. As you can see in the presentation, properties from horizontal axis differs from vertical axis, same as the standard and general equations. The standard equation for vertical parabola is x minus h quantity squared equals 4p times the quantity y minus k, while for horizontal, we use y minus k quantity squared equals 4p times the quantity x minus h. So now that we identified the properties and equations in parabola, let's now proceed to the given examples. So first example is x squared minus 8x plus 8y equals 0. So in order to identify the properties of this equation, we must convert it first into the standard form. First step is to group the number with the same variables and transpose the others into the other side. So we now have x squared minus 8x plus blank equals -8y plus blank. So next is we must find a perfect square numbers to fill in the blanks. So in order to find the perfect square numbers, we must divide 8 by 2 and square it. So 8 divided by 2 is 4 and 4 squared is 16. So as we add 16 on the left side, we must also add the same on the other side. And now we can factor out the equations, giving us x minus 4 quantity squared equals 8 times the quantity y minus 2. So as you can see, negative 8 is 4p. So we can divide it into 4 to find p. So p is equal to negative 2. So now that we identified the standard equation, we can now identify its properties. For its axis, it is vertical, since we use the standard equation of vertical parabola. For its opening, it's downward, since 4p is negative. For its vertex, it's 4, 2, focus, 4, 0, directrix y is equal to 4, and latus rectum is 8. Let's have another example. Y squared plus 12y minus 4x plus 16 equals 0. So again, we group the numbers with the same variables and transpose the others into the other side of the equation. So we now have y squared plus 12y plus blank equals 4x minus 16 plus blank. So now we fill in the blanks with the perfect square numbers. 12 divided by 2 equals 6, 6 squared equals 36. So now that we fill in the blanks, we can now factor out. We now have y plus 6 quantity squared equals 4x plus 20. Factor out the 4x plus 20. So we now have y plus 6 quantity squared equals 4 times the quantity x plus 5. Given that 4p is 4, 4 divided by 4 equals 1. So p is equal to 1. So now that we identified the standard equation, we can now identify its properties. For its axis, it's horizontal since we use the horizontal standard equation. For its opening, it's right since the 4p is positive. Vertex is negative 5, negative 6. Focus is negative 4, negative 6. And directrix is negative 6. Latus rectum is 4. So now that we have learned how to identify the properties from the given general equations, let's try to solve the general equations from the given properties. Let's have an example. The given is upward, vertex is 3, negative 2, y is equal to negative 5. So given that directrix is k minus p is equal to negative 5, substitute k by negative 2. So negative 2 minus p is equal to negative 5. P is equal to 5 minus 2. So p is equal to 3. So in order to get 4p, multiply them both sides by 4. So 4p is equal to 12. So now that we have h, k, and 4p, we can now identify the equation. So given that the equation is upward, we can use the vertical standard equation. So it is x minus h quantity squared equals 4p times the quantity y minus k. Substitute the numbers. So we now have x minus 3 quantity squared equals 12 times the quantity y plus 2. So let's expand. X squared minus 6x plus 9 equals 12y plus 24. So move the 12y plus 24 to the left side. So we now have x squared minus 6x minus 12y plus 9 minus 24 equals 0. So combined like terms, we now have the general equation x squared minus 6x minus 12y minus 16 equals 0. So let's have one last example. So the given here is left, vertex is 4, negative 3, latus rectum is 4. So given that the opening is left, it is horizontal. And by horizontal, right is positive and left is negative. So since the given is left, the 4p is negative. So now let's solve for the equation. We can use the horizontal standard equation. Y minus k quantity squared equals 4p times the quantity x minus h. So let's substitute y plus 3 quantity squared equals negative 4 times the quantity x minus 4. And then let's expand. Y squared plus 6y plus 9 equals negative 4 plus 16. So move negative 4 plus 16 to the left side of the equation. So we now have y squared plus 4x plus 6y plus 9 minus 16 equals 0. So combined like terms, so we now have the general equation y squared plus 4x plus 6y minus 7 equals 0.
The next topic that we are going to discuss is ellipse, with its properties and equations. So, what is ellipse? Ellipse is a set of all points in a plane where the sum of the distance of two fixed points are constant. As you can see in the presentation, the properties of ellipse consist of axis, center, two foci, two vertices, two co-vertices, major axis, minor axis, and latus recti. Furthermore, the standard of equation for ellipse is quantity x minus h quantity squared over a squared plus quantity y minus k quantity squared over b squared is equal to 1, by which can be either vertical or horizontal. For vertical ellipse, b squared should be greater than a squared, while for horizontal, a squared is greater than b squared. Now that we have identified the equations and properties of ellipse, let us now proceed to the given examples. Now, for the first example, x squared over 144 plus quantity y minus 1 squared over 121 is equal to 1. To get the properties of the example, we should get h, k, a, b, and c. Since the first term is x squared, h is 0. And from the second term, quantity y minus 1, quantity squared, k is positive, a squared is 144, while b squared is 121. The square root of a squared is 12, while the square root of b squared is 11. To get c squared, we can subtract a squared and b squared, derived from the Pythagorean theorem. 144 minus 121 is equal to 23. To get c, we can square root 23, which is equal to square root of 23. Now, onto the properties. The axis is horizontal as a squared is bigger than b squared. For center, we just write h and k, which is 0, 1. Next is the foci. To get this in a horizontal equation, h plus or minus c should be followed. f1 is square root of 23, 1, while f2 is negative square root of 23, 1. Next is the vertices. Referring to the table, v is h plus or minus k, thus making v1 as 12, 1, while v2 as negative 12, 1. For the vertices, k plus or minus v should be followed. Thus, cv1 is 0, 12, while cv2 is 0, negative 10. Next is the major axis, which is 2a for horizontal. 12 multiplied by 2 is 24. For the minor axis, it is 2b. 11 multiplied by 2 is 22. For the latus rectum of horizontal, it is 2b squared over a. 121 multiplied by 2 over 12 is equals to 244 over 12, which can be simplified to as 121 over 6, or 20 and 1/6. For the next example, it is a general equation of an ellipse, wherein we are going to find the properties. The example is 4x squared over 25 plus y squared over 100 is equal to 1. Again, we are going to get h, k, a, b, and c to get the properties. H and k are 0, while the square root of a squared is 5, and the square root of b squared is 10. In getting c squared, 25 is subtracted from 100, which is 75. To get c, we should find the square root of 75. 75 is factorable by 25 and 3, thus making c 5 square root of 3. Now that we have value for h, k, a, b, and c, we can now get the properties. The axis of this equation is vertical, as b squared is bigger than a squared. The center is 0, 0, since h and k are both 0. The next one is the foci, which is k plus or minus c, given in the table. f1 is 0, 5 square root of 3, while f2 is 0, negative 5 square root of 3. In the vertices of a vertical ellipse, it is k plus or minus v. For v1, it is 0, 10, and for v2, it is 0, negative 10. Now, for the co-vertices, it is h plus or minus a. CV1 is 5, 0, while CV2 is negative 5, 0. For the major axis of a vertical, it is 2v. 10 multiplied by 2 is 20, and for the minor, it is 2a. 5 multiplied by 2 is 10. Lastly, for the latus rectum, it is a squared multiplied by 2 over b for a vertical ellipse. 25 multiplied by 2 over 10 is 50 over 10, or 5. For the third example, only the properties are given. The center is negative 2, 3, while the foci is negative 2, 4, and negative 2, 2. The vertices are also given, which is negative 2, 5, and negative 2, 1. To get our general equation, which is ax squared plus by squared plus cx plus dy plus e is equal to 0, we need to get h, k, a, and b. We can tell that this equation is vertical since the h has a constant value. Since the center is given, h is negative 2 and k is 3. For now, we are going to skip a to show how to use Pythagorean theorem in solving the general equation. To get b, we can either add or subtract the k of the vertex to the k of the center. In this equation, we are going to subtract 5 and 3, which is equal to 2, thus b is 2. There are also some instances that we are going to find c to utilize the Pythagorean theorem in getting a or b. Thus, c is 1. Now, let's solve for a. We are going to utilize a squared equals b squared minus c squared. A squared is equal to 4 minus cancel the square root of a squared to get a, thus giving us a is equal to square root of 3. Now that we got the needed variables, we can now solve for the general equation. First, substitute the value of h, k, a, and b. Thus, this will give us quantity x plus 2, quantity squared over 3, plus quantity y minus 3, quantity squared over 4 is equal to 1. The next step is that we should divide all sides by lowest common denominator, which is 12. This will give us 4 quantity x squared plus 4x plus 4 quantity plus 3 quantity y squared plus 6x plus 9 quantity is equal to 12. We can now expand this equation to get the general form. This will give us 4x squared plus 16x plus 16 plus 3y squared minus 15y plus 27 minus 12. The 12 is transposed to the other side, making it negative. Now, we can combine the like terms. 16, 27, and negative 12 are similar, thus we should combine them, which will give us 31. After this, we can now arrange them accordingly to the general equation. Now that we have 4x squared plus 3y squared plus 16x minus 18y plus 31 as the final answer. For the last example, only the given are properties. The foci is 1 plus or minus square root of 7, 0. The vertices are 5, 0, and negative 3, 0. The minor axis is 6. The k has a constant value, which makes the ellipse a horizontal one. Similar to the third example, you should get the value of h, k, a, b, and c in order to get the general equation of the given properties. Since it is indicated, c is square root of 7, k is 0, while h is 1. To get a, we can add or subtract the h to the vertices, thus 5 minus 1 is 4. To get b, we can derive it from the minor axis, which is 6. Simply divide the given to 2, thus b is 3. Now that we have completed the needed variables, we can now substitute the standard form, which will give us quantity x minus 1 quantity squared over 16 plus quantity y minus 0 quantity squared over 9 is equal to 1. We are going to divide all sides with the LCD of a squared and b squared, which is 144, thus giving us 9 quantity x squared minus 2x plus 1 quantity plus 16y squared is equal to 144. Expanding the equation, it will give us 9x squared minus 18x plus 9 plus 12y squared. Then the 144 is transposed to the other side. Arranging it to the general equation, it will be 9x squared plus 16y squared minus 18x minus 135 is equal to 0. This is the final answer.
So let's move on to our last lesson, which is solving hyperbola and its equations and properties. So first, what is hyperbola? Hyperbola is a set of all points in a plane where the difference of the distance of the two fixed points are constant. So as you can see in the presentation, hyperbola is somewhat similar to ellipse. The only difference is the sign on the standard equation and how they call its properties. For hyperbola, the standard equation is subtraction. Its properties consist of axis, center, foci, vertices, endpoints, transverse, and conjugate axis. So now that we identified the properties and equations in hyperbola, let us now proceed to the given examples. So the first example is y plus 2 quantity squared over 64 minus x minus 2 quantity squared over 49 equals 1. So now let's find h, k, a, b, and c. So in this equation, 64 is equal to b squared and 49 is equal to a squared. So h is equal to 2, k is equal to negative 2, a is equal to square root of 49, which is 7, b is equal to square root of 64, which is 8, and to find c, we have a squared plus b squared equals c squared. So substitute 49 plus 64 equals c squared. So 113 is equal to c squared. So RC is equal to square root of 113. So now that you identified its parts, let's now proceed to its properties. For its axis, it is vertical since the b squared is greater than a squared. The center is 2 and negative 2, foci 2, comma negative 2 plus square root of 13, 2, comma negative 2 minus square root of 13. For its vertices, we have 2, comma 6, and 2, comma negative 10. Its endpoints are 9 and negative 2, negative 5, and negative 2. So its transverse axis is 16 and its conjugate is 14. So let's have another example. 9x squared minus 4y squared minus 36 equals 0. So transpose negative 36 to the right side. We have 9x squared minus 4y squared equals 36. Divide both sides by 36, we can now have x squared over 4 minus y squared over 9 equals 1. So now we find h, k, a, b, and c. So for a squared, we have 4, b squared, we have 9, h is equal to 0, k is equal to 0, a is equal to square root of 4, which is 2, b is equal to square root of 9, which is 3, and to find c, we have a squared plus b squared equals c squared. So 4 plus 9 equals c squared. 13 is equal to c squared, square root of 13 equals c. So now that we identified its parts, we can now identify its properties. So for its axis, we have horizontal. Center, we have 0, 0. For foci, we have square root of 13, 0, negative square root of 13, 0. For vertices, we have 2, 0, negative 2, 0. For endpoints, we have 0, 3, 0, negative 3. For transverse, we have 4, and conjugate, we have 6. So now that we have learned how to identify the properties from the given equations, let us now identify general equations from the given properties. So let's have an example. For the given, we have horizontal, center is negative 3, 2, vertex is 2, 2, and the conjugate is 8. So given these properties, we can identify h, which is equal to negative 3. K is equal to 2. So to find a, we can substitute h plus a equals 2. So substitute h by negative 3. Negative 3 plus a equals 2. A equals 2 plus 3. A equals 5. And to find b, we divide the conjugate by 2. So 8 divided by 2 equals 4. So b is equal to 4. So now that we identified its parts, we can now substitute it to the standard equation. So the standard equation for horizontal is x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. So substitute, we have x plus 3 quantity squared over 25 minus y plus 2 quantity squared over 16 equals 1. Multiply both sides by 400, we can now have 16 times the quantity x squared plus 6x plus 9 minus 25 times the quantity y squared plus 4y plus 4 equals 400. So let's distribute. We have 16x squared plus 96x plus 144 minus 25y squared minus 100y minus 100 minus 400 equals 0. So combined like terms, we can now have 16x squared minus 25y squared plus 96x minus 100y minus 356 equals 0 as your general equation. So let's try another example. So the given axis is vertical. The vertex is 0, 4. The endpoints is 2, 0. So given these properties, we can easily identify h, which is equal to 0, k equals 0, a equals 2, and b equals 4. So now that we identified the parts, we can now move on to the standard equation. So the vertical standard equation is y minus k quantity squared over b squared minus x minus h quantity squared over a squared equals 1. So substitute the value. We have y squared over 16 minus x squared over 4 equals 1. So multiply both sides by 16. We now have y squared minus 4x squared equals 16. Transpose 16 to the other side. We now have y squared minus 4x squared minus 16 equals 0. So in order to arrange, multiply them again both sides by negative 1. So we now have 4x squared minus y squared plus 16 equals 0 as your general equation.
God.